This video is on the topic of current, including the difference between conventional current and electron flow. So what is current? Current is the flow of charged particles. In a circuit, those charged particles are electrons. More specifically, current is the amount of charge passing a fixed point per unit time. Let's take the ammeter as the fixed point. If we were to count the amount of charge passing through the ammeter every second, then we would have a value for current. And that's exactly what an ammeter does. It measures the charge passing through it each second. That's why an ammeter needs to be positioned in series so that the charge flows through it. If we break the circuit, the current stops everywhere all at once. And more importantly, if we complete the circuit again, the current flows again everywhere all at once. There are so many misconceptions about electricity, one of them being that charge is stored in the cell, and so current flows from the cell. This is not true. Current flows from everywhere in the circuit, and it flows through the cell. The electrons in a circuit are the outer electrons from the atoms that make up the circuit. We call them delocalized electrons. Roughly one outer electron per metal atom is free to move around within the structure of a metal because of the way the metal atoms bond together. These delocalized electrons will flow when under the influence of an electric field. And that electric field is created by the positive and negative terminals of the cell and the surface charges along the wires. That's what current is, the flow of these charged particles or electrons. Electrons are negatively charged, therefore they are attracted to the positive terminal of the cell or battery. That means that electrons flow in this direction. However, when electricity was first discovered and put into use, the electron had not yet been discovered. Scientists thought that it was positive charge that flowed around the circuit in this direction. We call this conventional current. So electricians work with conventional current, and all the circuit problems on your exam paper work with conventional current. But when we're looking specifically at the electrons, we know that they flow the other way around. This is called electron current. There are two ways that current can flow around a circuit. If the source of potential difference in the circuit is a cell or a battery, then the current will flow in one direction only, forwards. We call this direct current. If the source of the potential difference is from the main supply, then the current will alternate directions. It will flow forwards, then backwards, then forwards, then backwards. We call this alternating current. Let's take a look at an example exam question. A student sets up the circuit as shown in the diagram. A charge of 3.8 coulombs flows through the resistor in 0.8 seconds. What is the current through the resistor? Which direction do electrons flow through the resistor? And what is the direction of conventional current through the resistor? Okay, so we know that the focus of the question is through the resistor. Let's start with current. We know that the current is the charge passing a fixed point per unit time. And we're told that the charge was 3.8 coulombs and that the time taken was 0.8 seconds. Substituting in those known values gives 3.8 coulombs divided by 0.8 seconds, which gives us a current of 4.75 amps. This discounts answer options B and D. So which way do the electrons flow through the resistor? Well, we know that electrons are negatively charged, so they are attracted to the positive terminal of the cell. Therefore, electrons will flow towards the positive terminal, this way. So through the resistor, they travel from left to right. That discounts answer option C. Now, it looks like we've got to the correct answer, but there is one piece of information left. So it's important to check that it fits with our answer so we know we haven't made a mistake. If the electrons travel from left to right, the conventional current should be going in the opposite direction, from right to left. That all checks out, so we can be confident that the answer is A for 1 mark. In summary, current is the rate of flow of charge, or the amount of charge passing a fixed point per second. Ammeters measure the amount of charge flowing through them every second, and they can only do this if they are positioned in series. Conventional current is the direction that a positive charge would flow around a circuit. This is from positive to negative and is the opposite direction to electron current, which is the direction that those delocalized electrons actually do flow around a circuit. Electrons are negatively charged, so they flow towards the positive terminal. And finally, current can either be direct or alternating. Direct current occurs in circuits with cells or batteries, and the current flows in just one direction. Alternating current occurs in circuits that are connected to the main supply, and the current alternates between flowing forwards and backwards. Don't forget to check out all our other fantastic revision resources here at Save My Exams.